Hi, this is Andrea Hendricks. Hope you guys are doing well today. This is a video on problems from section 5.4 homework. Looking at problem 2 from my math lab says the graph of the exponential function f of x is equal to 1/4 to the x is given with 3 parts, or 3 points. Determine the following for the graph of f inverse of x. So first let's make sure we remember what the exponential function looks like. 1/4 to the x. Remember that's also the same thing as 4 to the negative x. But we have a point on here. What is that? -1, 4, 0, 1, and I believe that would be 1, 1/4. Well, do you remember that if the point xy is on f, the point yx has to be on f inverse, right? Because the x and the y are interchanged on a function and its inverse. So what we're looking for the graph of f inverse is we're looking for a graph that contains the points 4, -1, 1, 0, and 1/4, 1. Now also notice that we have a horizontal asymptote at y is equal to 0 for the exponential function. So that would mean we need a vertical asymptote at x equals 0. So we're looking for a vertical asymptote at x equals 0. So that would not be the case. This would not be the case. This would not be the case, and do you understand why those are not? Because all of those actually cross that point or that line, x equals 0, which cannot happen with a vertical asymptote. By process of elimination, it has to be D, but also confirm that the point 4, -1 is there, 1, 0, and 1/4, 1. So this would be your answer. Now, it also asks 3 other parts to determine the domain, the range, the equation of the vertical asymptote, which we've already talked about. I guess 4 parts, and then is it increasing or decreasing? So just remind yourself that the domain of this inverse function is from 0 to infinity. The range is from -infinity to infinity. And the vertical asymptote we've already talked about, and it is a decreasing function. Okay, and notice how that compares to this exponential, right? Remember with exponential, the domain is -infinity to infinity, but the range is from 0 to infinity. So those have interchanged roles. Now, number 3 says the graph of the exponential function y is equal to 3 to the x given with 3 points. Determine the following for the graph of f inverse of x. Well, we could also do that. This one has a horizontal asymptote at y is equal to 1, right? It has a key point instead of 0, 1, it's at 0, 2. And the point 1 has an output of what? 3 to the first is 3 plus 1, which would be 4. And we could also put in -1, so it would be 1/3 plus 1, which would be 2/3. So you have the point -1, 2/3. So when we interchange all of those points, again, we're looking for now a vertical asymptote at 1, okay? And then the point 4, 1, 2, 0, and 2/3 -1. So a vertical asymptote at x equals 1, 4, 1, 2, 0, and 2/3 -1. Okay, so the only one with a vertical asymptote at x equals 1 is this b. Now, do you remember how to find, if we needed to find the equation of the inverse function? Let's just review that for a minute. Remember that y is equal to the x plus 1, and then we would have to interchange our x and our y to get x is equal to 3 to the y plus 1. And then I could subtract 1, x minus 1 equals 3 to the y, and therefore this is equivalent to the log base 3 of x minus 1 is equal to y. Okay. So that is a shifting right 1 unit of that basic log function, which is why this also is a reason that that works. Now, the next few problems that I have on this one page are to determine the domain. And so to determine the domain, remember that the input has to be greater than 0. So the log of 7x plus 5 would have a domain where 7x plus 5 has to be greater than 0. So if we subtract 5, we get 7x is greater than negative 5, and divide by 7 to get negative 5 sevenths. So our domain would be from negative 5 sevenths to infinity. The domain of natural log of x squared plus 7, we would have to find where x squared plus 7 is greater than 0. This would give us where x squared is greater than negative 7. But if you think about that, x squared is always positive, which is always greater than negative 7. So this is always true for all values of x. And so this would mean that the domain is negative infinity to infinity. Okay. Now, to find the domain of x log base 7 of x squared minus 2x minus 35, we have to find where x squared minus 2x minus 35 is greater than 0. So we have to set that to 0, and that actually factors x minus 7 times x plus 5 is equal to 0. So this is x equals 7 or x equals negative 5 are the solutions to that equation. So if we put those on the number line, and remember how x minus 2x minus 35, if we graph that, that's a parabola that opens up. So knowing that tells us that the solutions where this parabola is greater than 0 or above the x-axis occurs in these outer regions. We cannot include the points because we're strictly greater than. So our domain would be negative infinity, excuse me, to negative 5, union 7 to infinity, which is B. Identify the graph of log base 4 of x minus 3. So this is translation that we need to do. This one is a shifting down 3 units. So to shift down does not change the vertical asymptote. So we're still going to have a vertical asymptote at x equals 0. And then our key point of 1, 0, if it shifts down 3 units, would be what? 1, negative 3, right? Down is only affecting the y values. So we should be looking for one that has a vertical asymptote at x equals 0 and it's shifting down. So we would want it to look something like this. And that one is A. Okay, now it's eventually going to cross the x-axis, so don't think that that's another asymptote there. Now, determine the graph of f of x is equal to e to the negative x minus 2. So this brings back into play those exponential functions. So remember that with a negative x, that's going to involve a reflection. To take the opposite of x means that's going to reflect across the y-axis. And we also have a shifting down of 2 units. So remember, e to the x looks something like this. It goes through the key point of 0, 1. So to reflect across the y-axis is going to make it look like this. And then it's got to go down 2 units. And so that asymptote also goes down. And that key point of 0, 1 goes down to 0, negative 1. So it should look something like this. Okay. And that looks like C. Choose a correct graph of f of x equals the natural log of x minus 3. So the natural log of x minus 3 is a shifting of the basic function. It's a shifting right 3 units of natural log of x. So remember, to shift right means our vertical asymptote is going to shift right 3 units. And our key point of 1, 0 is going to go to 4, 0. And natural log has a base of e, which is greater than 1, so it's an increasing function. And so this is a graph that we should be looking for, and that's going to be right here. Notice the scale is going from negative 10 to 10, so those are counting by 2, so that is a 0.40 right there. Now, evaluate log base 16 of 8 analytically. Well, let me just say, if you want to calculate it, remember that log base 16 of 8 would really be the common log of 8 over the common log of 16 by the change of base formula. But if we want to say that log base 16 of 8 is equal to, let's say, y, to do this analytically, we would have to say 16 to the y is equal to 8, right? Convert from the log to the exponent. And then this is one of those type 1 exponential equations. We have to convert the left side and the right side to the same base. 16 is the same thing as 2 to the 4th power. And 8 is the same thing as 2 to the 3rd power. So we really have that 2 to the 4y is equal to 2 to the 3rd power. And remember that if your bases are the same, then your exponents have to be equal. So that tells us that 4y is equal to 3. So y is equal to 3 over 4. Now, the next one, f of x is equal to 3 to the x minus 2 is 1 to 1, and it's an exponential function. We want to find f inverse analytically. So kind of what we talked about a little bit earlier. If we say y is equal to 3 to the x minus 2, and then we interchange our x and our y to get x is equal to 3 to the y minus 2, and now we need to solve for y. So we would add 2 to both sides, and then if we want to bring the y down or get y by itself, we have to do the operation that will remove that, which is the log base 3 of x plus 2 is equal to the log base 3 of 3 to the y. So log base 3 of 3 to the y is just simply y is equal to the log base 3 of x plus 2. Okay, and so this would be the answer. And then the last problem says students in an accounting class took a final exam. They took equivalent forms of the exam in monthly intervals thereafter. The average in percent after t months is given by the function s of t is equal to 75 minus 13 times the log of t plus 1, where t is greater than or equal to 0. It says to find the average score when they initially took the test and then also 3 months later. So if we want to find the average score when they initially took the test, t would be 0 months. So we'd have to find s of 0, which is 75 minus 13 times the log of 0 plus 1. So in this case, we're going to get 75 minus 13 times the log of 1. What is the log of 1? Yeah, we're thinking of what power of 10 gives us 1, and that is 0. So this is really 75 minus 13 times 0, which is just going to be 75. Okay. And then it said to find the score when they took it 3 months later. So 3 months later, we're going to plug in 3 for t. 75 minus 13 times the log of what? 3 plus 1. So we're just going to use our calculator to find 75 minus 13 times the log of 4. So 75 minus 13 times the log of 4. 67.12, it said round to the nearest integer, so 67 would be our answer. Okay. And then it says to graph the function and find at what time the average score was 50. So if you wanted to graph that on the calculator, 75 minus 13 times the log of x plus 1. Now you're going to have to change your scale, right, because we're looking for a y value of 50. So we know that we need to change the y max to be, let's say, 70, just to include it there. And our y scale, maybe we'll count by tens. Okay. So you should see something graphing there. And then to solve that, like this is what I have in my window. I'm going from -10, 70, and -10 to 10. And I see something coming up in the upper first quadrant. It looks like that. So if I'm trying to find when it's equal to 50, remember I can do the intersection, or I can do trace. There's a lot of things I can do to find out where those two things are equal. And when I do 50, I get this line, and they're not intersecting between -10 and 10. So if I want to see that on my calculator, I'm going to have to change my x max. So maybe let's change it to 30 and change my scale to 5. I would do this at the same time, but the program I'm using does not like me to use another software because it slows down the audio. Okay, so even when I changed it to 30, they're still not intersecting. So let me change my window. So my x max now is 50, and my scale is 10. Almost intersecting, so let's change my x max to 100 and count by 20s. Okay, and I see them intersecting. So now I can do second, trace, and intersect. First curve enter, second curve enter, and a guess. And it is at 82.7, or roughly 83 months for the score to be a 50. Okay. So what I had to do for that one is I had to set my x max to be 100 and y max I set to be 70. And then I saw it. Okay, and that is all that I was going to show you on this video. So if you have any questions, don't hesitate to contact me. Thank you.